Name the parts of the right triangle. No problem. In fact, they're not showing it, but maybe they should. There is a right angle right here. Sometimes they'll indicate it with this kind of a square box right there. That is a right angle, and a right angle tells us that we're looking at a 90-degree angle, okay? So if you see a box like this one, you should know that you are looking at some kind of right angle there, which is important because that's what makes it a right triangle. Any triangle that has one right angle, a 90-degree angle, is considered a right triangle. And then you have two other parts to this. So there's two parts. You have this part right here and this part. These two are both considered, or they're classified the same. These are what we call legs. So this red side length right here would be called a leg. And then this other red side also is called a leg. The two legs are what make up the right angle. Now, a triangle only has three sides. So you got the two sides, legs, that make up the right angle here. But then you have the other side length, which is not part of the right angle. And that is what we call a hypotenuse. So hypotenuse. And did I spell that correct? I don't know. Also, I don't care, but it's close enough, even if it's not spelled correct. So this is what's important for us to remember on right triangles. Today, as we start Unit 8, when we look at a right triangle, you have legs, and then you have a hypotenuse. And of course, a right angle, which makes it a right triangle. And if we can know that, then it's going to help us with at least some of the problems that we look at today. But this is all review stuff that we should have seen before. Yeah, I know when triangles are or are not congruent. So take 15 seconds, copy that down, and then we'll get started. All right, a quick note here on the word congruent. Congruent just means that things are the same, sides are the same, and then angles are the same, which means that you're looking at a shape. It should be exactly the same shape, so I can't really say that a triangle would be congruent to a square, because they're not even the same shape. But they have to be the same shape, same sides, same angle. So it can't be bigger or smaller. It has to be the same exact size, and it has to be the same shape. In the past, when you've seen this, you've probably seen it with this symbol, which is the congruence symbol. It's just another way to say that we're looking at shapes, and they are the same, right? But we can use the symbol with both sides and angles, which is what we're going to be looking at today. So before we get started, it's important to notice that on these shapes, sides are usually marked with ticks or tallies. I don't know, tick marks should probably work. Something like this one, okay? Now this has one mark. Over here, this side has one mark. And over here, this side has one mark. If they have the same markings on either a side or an angle, then you know that you're looking at the same length of side or the same measure of angle. Or for example, let's say it can happen within the shape as well. So maybe like if this angle had one mark and this angle had one mark right here, this mark only being one angle mark and this mark being only one angle mark would indicate that the two angles are the same. Now, do they look the same? They do not. And so don't always expect the shapes to look the same because we just want you to get used to seeing the markings, even though the shapes may not look the same. Or if we wanted to, let's go to that middle triangle right there. Let's say the angle that has one mark, let's say it was two marks instead. Okay, so again, this would indicate that this angle, now having two marks like this angle, they're the exact same angle, even though they don't look the same. Okay. Now, if they're different, like these are now, with one mark and then two marks, now we would say that these two are different, all right? And if we were to go to that third angle and say, look at this angle marking right here, but it has three angle marks, now we would say all three are different. But if we took one away and said this one has two, now it's the same as that other one. So the markings are not just to say you have a side or an angle, it's also to tell you that the sides are the same or the angles are the same. So it's important to realize what the markings are, how many marks there are, and what type are being used. So if we can understand that, then the rest should go pretty well. Hopefully you noticed that this third triangle over here to the right, this is showing a 90-degree angle, this one right here, which means we're looking at a right angle. And so just to re-emphasize what we saw on the bell work, you'd have two legs here and here. These would be legs. And then the side that doesn't make the right angle would be the hypotenuse. So I'm trying to emphasize this vocabulary because, at least for me, it's the right triangles on the assignment that they trip me up the most, because I just don't notice the right angle. We're going to see more of these two types of triangles than we will the right angles. So just be aware, if you see something unusual, just check to make sure that angle mark is not a square. Because if it is, then it creates a unique situation, even when we're looking at the congruent triangles conditions. But the last thing I'll say about these, though, is that these markings are not telling you that you have to measure stuff, right? I don't need to know the lengths of the sides. The marking just tells me if it's the same as the other triangle. And I don't need to measure angles with a protractor because, again, I just need to know if the angles are the same between two triangles. Technically, you can do it with more triangles, but we just need to, for today's lesson, all we're comparing is two triangles at a time. So, congruence in shape. Remember, a congruence symbol is going to look like this. You're going to see this, not just with shapes, but we can have congruence between side lengths, and we can have congruence between angles as well. So, when two or more shapes have the same angles and the same side lengths, then we would say that the two shapes themselves are congruent. Now, orientation may change. This is important as well because it trips up some students too. So if I were to take this, let's say this triangle right here, and let's say that I duplicated it like this. Now, I just copied and pasted that, so I know that it's the exact same triangle, I just moved it, right? But what happens is on the assignment, what they're going to do is they're going to take that shape and they're going to rotate it like this, and then they're going to say, okay, can you tell that they are congruent or not? And if you can tell, based on the congruence statements that we're going to be going over, then you can say that they are congruent, okay? So be careful because, like I said before, like this side, and maybe this side and this side, right? So I've got 1, 2, and 3 marks. Maybe over here, you got 1, 2, and 3 marks like this, okay? But sometimes what they'll do is they'll take those last 2 marks there and they'll just kind of switch them like this. And I don't know why that's so confusing, but again, it's just, you got to look at the number of marks on each of the lines to make the determination if they're congruent. But again, the markings are telling us that they are congruent. For example, this side length that has only 1 green mark, and this side length that have only 1 green mark, those 2 side lengths would be considered congruent. Same with the side length with 2 markings, here and here. Of course, they're kind of located differently because of the way that I did the triangles. But again, those 2 purple side lengths would be congruent, and then same with this last side length that I'm putting in orange. It would be these 2 side lengths on different triangles are still congruent. And if we can see this relationship, if you have 3 sides of a triangle that are congruent with 3 sides of another triangle, automatically we would also consider these 2 triangles congruent in addition to their sides, in addition to, well, corresponding sides, and then in addition to their corresponding angles. So while that probably is clear as mud, let's take a look at the congruence statements for triangles. All right, so we have congruence statements for triangles, that's these 5, and then we have non-congruence statements. These 2 statements here at the bottom just tell us that if we see this relationship between 2 triangles or more, then we just can't guarantee that they're the same. They could be the same, we just can't guarantee that they will be. So we say that these 2 statements would just be kind of like non-congruence statements, but it's just that we're not guaranteeing congruence. So what does this all mean? Because there's a lot of math mumbo jumbo, but S stands for side, A stands for angles, and then we see over here you have a hypotenuse and a leg. These 2 right here are for right triangles. Now you notice over here I've written right triangle. That's because the word triangle is too much writing for me. So I like to use the math symbol, and I know my drawings suck, but that's a triangle right there. So it's a right triangle. And then we see down here the hypotenuse leg relationship between triangles. If we see that, then we can guarantee congruence, okay? But we have these other ones, side, side, side. Again, the S stands for side, so SSS is side, side, side. Or we got this one, SAS, which would be side, angle, side. ASA, angle, side, angle, ASA, and then AAS, angle, angle, side. By the way, AAS can be written as SAA. It's the same, it would have the same relationship, it's just in backwards order. Side, angle, side, doesn't matter if you go backwards. Same with angle, side, angle. Hypotenuse, leg, yeah, you can go leg, hypotenuse, whatever. Now, that's, what is that, 5, it's really 5 statements right here that you have to memorize. You don't have to memorize those. I just memorized these 2 because it's a lot easier to memorize 2 than 5. So, down here at the bottom, if we see that a triangle, 2 triangles have the same angles, all 3 angles are the same, then we cannot guarantee that the 2 triangles are exactly the same size, and then the same lengths of sides. So we'll watch out for that one. This one right here, side to side angle, if we see this one, then again, we just can't guarantee that these are going to be congruent. Now some students, because, I mean, this is 9th grade class, right? And some students are like, well, I would like to do this as angle, side, side, and then they chuckle a little bit. Freaking grow up, okay? Because we should be way beyond that crap, all right? So when you're comparing features of the 2 triangles that they're going to give us, we're going to go around, and it doesn't matter which direction you go around in order to accomplish these. Like, you may find that one of the triangles going around, you may go clockwise and you say angle, angle, side. And then if you went continuously clockwise around the next one, you'd see side, angle, angle. It's the same relationship, it's just backwards. And it will work also for angle, side, angle, side, 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 side. And then hypotenuse, leg is really just for right triangles, okay? So it doesn't matter which direction you go around the shape, the triangle, as long as we have these conditions. So again, you could go clockwise and find angle, angle, side, but you may need to go counterclockwise on the other one to get the same angle, angle, side, if it matters to you. Now, when we compare these, and this still probably doesn't make sense because we haven't done any examples, but when you compare these, you can't skip more than one part of the triangle at a time, meaning you can skip an angle to get to another side. Like, let's say I wanted angle, angle, side, right? So let's look at a triangle right here. So angle, angle, side. So I can have an angle here, I can have an angle right here, and then I can have a side right there. But some students get this mixed up because they're like, you can't compare these 2 angles because they're not, you have to skip a side. Yeah, I can skip one side, but I can't skip a side then an angle. So, for example, I couldn't say this is side, angle, angle right here, the way this is written. Well, I could go backwards, right? Side, angle, angle. But I can't go clockwise around because if I did, I would skip this angle and then this side. That's what I mean. You can't skip 2 parts of the triangle, an angle and a side. Sometimes some students have been skipping 3 parts. They'll skip an angle, a side, and then another angle in order to make these relationships. You can't do that. You can skip one part. For example, I did skip this side to get the angle, angle, side relationship, but I can't skip these 2 parts right here to make it side, angle, angle. Okay? So you have to keep that in mind because sometimes students get this they'll say side, side, angle, when in fact it's a side, angle, side relationship, okay? So I have to keep that in mind. And here are examples. So side, side, side. Now again, we've already seen an example like this, but it just means that all 3 sides of both triangles are exactly congruent with each corresponding part. So for example, if I were to mark this side and with 1 mark and then this one with 1 mark, those 2 red marks would indicate that the 2 sides there are congruent. Now if I gave this one 2 marks right here and maybe this one 2 marks, again, they may look like they're different. It doesn't matter if they look like they're different, they have the same mark, which tells us that those 2 parts are congruent. And then this last side length right here, if I give it 3 marks on both, then I have a side, and a side, which is congruent with a side, and a side. Side, side, side. Relationship tells us that these 2 triangles are in fact congruent. It's not my best congruent sign, but that's okay. Now, Did we skip a part of the triangle and to make in order to determine this side relationship? Yeah, we have a side, we skip an angle. We have a side, skip an angle. Side, skip an angle, whatever. But I can skip one part at a time, an angle or a side at a time. So for the next one, side, angle, side, so I'm going to kind of try to mix this up a little bit again. If this side is congruent to this side, then it checks off the side part of the relationship. Okay, now again, we can't skip more than one part, so the next one I'm going to say this angle right here in purple, and then we'll compare it with this one right here. I can do a little bit better. That's a little better. Now again, do these angles look the same? No, but it doesn't matter. They are congruent, so the two angles are congruent on the separate triangles. And then the last part right here, which would be that side, angle, side, so the next side would be this one. And put 2 marks there. And then we'll say this one. Side, angle, side for both triangles. Again, they may not look the same. It doesn't matter because the markings tell us that those are congruent. But that last side, the green side with 2 marks, tells us that the sides are congruent as well. Side, angle, side. And just remember, orientation doesn't matter. So let's say that I were to take, like this. I mean, these are oriented differently, but sometimes they may change the orientation quite differently. So they may take this one right here, and they'll say, let's compare these 2 triangles. And what they'll do is they'll kind of turn it or rotate it or flip it like this. And then they'll say, are they congruent? Yeah, these 2 are still congruent because of the markings. It's the markings that tell us that the side parts or the angle parts are congruent to each other, side, angle, side relationship. Now keep in mind, if I were to compare this as a side angle relationship, I can't do that because I would have skipped this angle, this side, and this angle to get to this side right here. Or if I went this other way, side angle, it's not side angle, it's side, angle, side. Yeah, I don't see side, I do not see, yeah, side angle is one of the ones that does not give us congruence. But these 2, the way they set up, are congruent. That was a better congruent symbol. Okay, so the next one, angle, side, angle. Now again, we can't skip parts here. So I'm going to start with an angle. We'll start with these angles, which again, those 2 angles in red are congruent. So there's an angles set that is congruent. Now I'm going to go clockwise through this one. So let's say that these sides are congruent right there. But I didn't skip any parts, and that's okay. And then the last part needs to be an angle. So we'll do the marking a little different for the angles. Like I said, you can use tally marks for the angles, but now those angles are congruent. Now, could you call this angle, side? No, because you've skipped this angle. Well, you've skipped the side, an angle, and a side. Which you cannot do when comparing these with these relationships. But having an angle, a side, and an angle in this way makes the 2 triangles automatically congruent, whether they look congruent or not. So angle, side, same idea. Maybe I've got this angle, which is congruent to this one here. And so the angles, the first angle that I have is congruent. The second angle, I'll go counterclockwise this time. So there's my second angle. And those 2 angles would be congruent with different marks. And again, some students say, well, you skip this side right here. I can skip one part. I skip that side, that's okay. But the next part needs to be right next to it as a side, which I'm going to say this side right here, 1 mark. So angle, side. Last one here at the bottom, these have to be right triangles because it says they got a hypotenuse leg relationship. So again, the 90 degree angles there in boxes, second one's okay, indicate that we are looking, in fact, at right triangles. But again, hypotenuse leg is only for right triangles. On some parts of the homework, what you're going to have to do is you'll have to say, I'm dealing with right triangles, and then say that it's a hypotenuse leg relationship, okay? So the hypotenuse for these, remember the hypotenuse is the side length that does not make up the right angle, which for these I'm going to keep in purple. I'm trying to keep the right triangle parts color-coded, but we can just give it 1 mark, which again, these 2 hypotenuses, or something like that, that would indicate that the hypotenuses are congruent with each other. Then all we need is one of the legs to be congruent. I'm going to do this one a little different. So I'm going to say, look at this leg right here. It's got 2 marks. If this leg is on the bottom, but it has 2 marks, it doesn't matter. So the orientation is different between these 2 right triangles. It doesn't matter. You have a hypotenuse and a leg that are congruent, which makes the 2 triangles themselves congruent. I should have done that with the last one, huh? Okay. So again, the hypotenuses are congruent, and the legs also are congruent. That's all we need. Assignment is going to start. It's going to give you these graphics like this, and then you have to determine the relationship, and then determine also if it is actually congruent or not. Remember that we don't get any of the side lengths or the angle measurements on these. For example, like this one right here, I don't know what this angle is, and I don't know what this is. I don't know what the side length is or this one. I don't know the measurements. In fact, I don't know these ones either. We don't have to know the actual measurements. I mean, if we did, then we could make the conclusion, but we don't actually have to know it. We can just use the markings for this. If they're not necessarily congruent, you got angle, angle, angle. So if you got 3 angles that are the same, and I purposely made these 2 not the same size, because if you have this angle, which is the same as this angle, and maybe this angle, which is the same as this one, and then this one is the same as this one. Now all 3 angles can be the same, but you see on these 2, which I've done on purpose, this one is just a copy of this one. It's just made smaller. It's been scaled down. But you see the side lengths are different sizes. So congruence means that the sides have to be the same, the angles have to be the same, and also, of course, then they would have to have the same shape. Okay? So automatically with these 2, you can have the same angles, but you can have different side lengths from having just 3 angles that are the same in triangles. Now we got side-side angle. So here's the problem with side-side angle. Now, some of you guys are seeing this. It looks like one triangle that has a line through it, which is true. I mean, that's how I made it. But this is telling us something different. And if I drawn it really well, I mean, it'd make more sense, hopefully. But what we have is 2 triangles built from a side-side angle relationship. Okay, so if the sides are the same, what happens is I got this side, and then I would have this side, and then an angle. But what the problem with that is if I were to take the outer triangle, so let's see if I can do this with some technology here. So I can take the same exact measurements here, and let's clean this up a little bit. Okay, not the best, but not the worst. This side actually can be the exact same as this side right here, but it makes 2 different triangles, which means that they're automatically not congruent. So this side just swung around here like this means that I have a side, and then a side, and then an angle. And then for this one, a side, and then an angle, which means automatically that these 2 triangles are not congruent because they don't even look the same. Now be careful, because on the assignment what they're going to do is they're not going to make them look so different. So what you can end up on the assignment is something like this one right here, and then I don't want that filled. Garbage. Okay, so they're going to give you a triangle like this one, and then they're going to give you pretty much another triangle that looks exactly the same, but they're going to show that you have a side-side angle relationship, side-side angle relationship. So even though they look the same, they are not the same or that we cannot guarantee that they'll be the same because of this side-side angle relationship. So I purposely made these 2 look different because that's what it would look like with a side-side angle relationship, or could. And then also an angle relationship too. They may not make these look different. Pretty much from here on, looking at today's work and also on mastery quiz next time, this is just a visual check, which means can you memorize these rules? And if you can memorize them, then this will go very smoothly for you. If you can't memorize them, just turn the page over and look at the relationships, because that's all you're going to need. Oh, this one's a little different. Are the following classified as side, angle, side, and then why? Side, angle, side. No, this one would not be side, angle, side, and here's why. So they're showing a side and then an angle, then a side, or you could say a side and then an angle and a side. But remember, what has happened is it skipped 2 parts of the triangle, meaning it skipped this angle right here, and then it skipped this side right there in order to make this a side angle side relationship. If you were to go counterclockwise, you could say side angle, this way because then you're only skipping an angle. Over here, you have angle, side, side, again, which works. But to go from side to this angle, you could go side angle, but again, you're going to have to skip a side and then another angle. Okay, you can't skip two parts of the triangle in order to make this relationship. You can skip one, you can skip an angle, you can skip a side, but you can't skip both a side and an angle while you're going around this, whether you're going clockwise or counterclockwise. It doesn't matter. Okay, so are the triangles classified as side, angle, side? And the answer is no. Why? Because to make the relationship side angle side, you have to skip a side and an angle. Boom. Which means that the actual relationship is side angle. That's it. This is the way it's kind of going to look like on the assignment. It's going to say two triangles are related by, gives us all the relationships. So the triangles are either congruent or not congruent. Okay? This one right here, all it's given us is we have an angle, and an angle compared with an angle, and an angle. So all three angles are congruent, but just like we saw a couple slides ago, angle relationship would not give us congruence. So on your drop-down list, you're going to have to choose this one because it is angle. But angle is one of those that cannot be proven to be congruent. Now again, could they be congruent? They could, but we can't prove that they are just with this information. So, before we continue to the next couple problems, just keep in mind that these types are nice because they will help you with some logical reasoning. And for those of you that suck at logic, get good at it, because if you suck at logic, it's very easy to trick you into believing things that are not true. All right, what is this relationship? Well, they've given us, going around the triangle, we have an angle. I'm sorry, that's a side. We have a side, and then another side, and then another side, compared with side. Which means that I am looking at a side comparison. And my side, oh, there it is. In the drop-down list. And just keep in mind when they give you the drop-down list, they may change the order of these. So side may not always be the third option, but the way I put these slides together, that's how it works. Side is good enough to say that the two triangles can be proven congruent. Okay? Remember, there was only two that would give us non-congruence, and that is angle, and side angle. These two bottom ones for this exercise. All right, the next one. Again, just look at this comparison. And I like to go clockwise around the triangle, so I have a side, an angle, and a side. And again, it's never skipping more than two at a time. So again, you can't say this is a side angle, because you'd skip an angle, a side, and then another angle. You skip three parts of the triangle. And then we compare this other one. You got a side, and an angle, and then a side. Side, angle, side, I can see right here. And again, if you can't memorize all five of them that make it true, hopefully you can memorize the two that make it not true. So again, it's not side angle, side angle, or angle. Therefore, it must make this congruent. All right, guys, take 30 seconds. Try this one. See how you do. See if you can figure out the relationship, and then see if you can figure out if it's congruent or not. All right, so this one is going to be congruent because what we have is an angle, then a side, and then an angle. Angle, side, angle. So, angle, side, angle, we can see right here. And again, the way I'm thinking about this is it's not one of the non-congruent statements, which means it has to be a congruent statement. Boom. So, angle, side, angle for this one. All right, let's see. How about this one? I guess I would call this one, just going clockwise around the triangle here, side, angle. But I think they do it as angle, side. Yeah, they're at the top. The next one as well, same idea, but going counterclockwise now. angle, side, angle, like this. So side, angle, or angle, side is exactly the same thing. Up here, this one. And it's not one of the non-congruent statements, which means it is congruent. Automatic. Now again, if you can memorize that those are all, the 5 of those are congruent statements, that's great. It's just, I don't have it memorized.
Congruent, but it's...
Just keep that in mind. If like this was a number right here, let's say that there were numbers right there. Let's say that this was 9, this one's 9, and then maybe this one's 50 degrees. So this one was 50 degrees. And then maybe this one over here, I don't know, 60 degrees. And then this one is 60 degrees. If I were to look at 2 triangles and they had values like this, instead of markings, that would be okay for me to say, look, since I get these values, and these values are the same with I guess it's angle, side, then that means that the rest of these, this angle is the same as this one, this side is the same as this one, and then this side is the same as this one. I can make that guarantee based on the way that these congruent statements work. This is the kind that gets me. Like, I look at this, and I would say, look, you got a side, and then an angle. I mean, you can say angle, side, just, don't do it because it's funny, because it's not. But side, angle is what I'm going to say on this one. The problem with this is that this is a right triangle. Boom. Right triangle, right triangle. So, in fact, we wouldn't look at this as any of the side angle relationships. We have to look at the one that is for right triangles, which is, it has to be a hypotenuse leg relationship on this one. Now, if it is, then it would be congruent. If for some reason it's just a leg-leg relationship, then we can't guarantee that they would be congruent, at least based off of these rules. So I look at this one, I see this is my hypotenuse. I know it is the hypotenuse because it does not make up the right angle. That's a hypotenuse. Same with this one right here. And they have the same 3 marks. The hypotenuses are congruent. So at least right now for my hypotenusi, I don't know, they are congruent. That's okay. All right, do I have legs that are congruent? Just a set of legs. That's all I need is one. Yeah, there's this one right here. It's got 2 marks. And then this one right here, it's a leg. It has 2 marks. How do I know that that's a leg? It's because it makes up the right angle. Now let's say that instead of the 2 marks being here, maybe it was right here. Well, that still shows that you have 2 legs that are congruent in separate triangles, which means that either way, the way this sets up, the legs are congruent, which means we have in fact found a hypotenuse leg congruency statement. And hypotenuse leg indicates that they are congruent, so I can just box this one in. Boom. Okay, what's the relationship here? Let's see. Okay, so once again, I cannot say this is angle, side, angle. Angle, side, angle. I cannot classify it that way because going from this angle to the side skips a side and then this angle right here. I cannot do that. But what I can do is classify this as side, angle, angle, because I go from this side to the angle. I can skip one part, which would be the side length on this one, to get to this angle. So at least this triangle, and then the next triangle as well, now going counterclockwise, side, angle, angle. So side, angle, angle, the way I'm classifying it is not shown here because they're kind of doing it backwards. Angle, angle, side, doesn't matter, it's the same thing. So I can say angle, angle, side, which means that it is congruent. The 2 triangles are congruent from that relationship. Okay, these 2, what do we got here? So once again, I cannot classify this as side, angle, because I'm skipping too many parts to get from this side to the side, or even going counterclockwise. I can't go from this side to this side because it skips an angle, a side, and then another angle right there. So I would have to classify this as a side, angle, side. What is this garbage? Okay, so this one, just again, going clockwise for this one, I had it as side, angle, side, like this one. This next one, though, it's built a little different. What I have is either angle, side, side, or more appropriately, side angle. So right here, just between these two, side angle and side angle side, they're just not even classified the same. So even though like this one has 2 marks and this one has 2 marks, they're positioned differently. See that right there? So you have to be careful on these. I don't know why it's showing like this, but whatever the case, they can't be classified as any one of these. So I don't know how that's going to work on the assignment, but I know for sure this cannot be proven congruent because of specifically this relationship. Now, if the 2 marks were here, then I could. I'd have a side angle side. But again, this one, to get from this side to this angle, you'll have to skip an angle and a side. That's 2 parts of the triangle, which we cannot do in classifying triangles this way. So on the second part of the assignment, you're going to have to actually name sides and angles for some of the problems. So what we end up with is, let's start with a triangle like this. And I'll try to make it look a little different. And what they'll do usually is they will label the corners of the triangles. Now they may get a little creative. For example, they may do ARC, and then in that way you could call it triangle car if you wanted to. Or I don't know how creative you can really get with 3-letter words. Like some students would say, this is triangle cab, and then they would chuckle a little bit, but that's usually 7th grade stuff. In any case, this is what we're going to call triangle ABC. Now, like I said before, I'm using a math symbol here, the triangle symbol, to represent the word triangle. This reads triangle ABC because I'm naming it based on the corners of this triangle. It's a lot better than actually writing the word triangle. Well, I think it is. When you name a side of a triangle, so if I were to look at, let's just start with this side right here. If I wanted to name this side of the triangle, I've got to use the 2 points that make up that side length, which would be A, then B for me. I'm going to say AB. So you got to use 2 letters, and we usually capitalize them on the assignment. If you do not capitalize these, it will not let you submit it. So make sure they're capitalized on the assignment. But then we just put a line over the letters. That indicates that this would read, you got line segment AB. It's really side length AB on triangle ABC. But you notice, I went from A to B, but you can actually go backwards. And so some students, I don't know, maybe they think this is funny, but they'd say it's side length BA. All right, whatever. It's exactly the same side length, and that's okay. Now you have 2 other sides, right? You got BC or CB, and then you got CA or AC side lengths as well. Well, this is how you would name a side length of a triangle. Angles, on the other hand, we're going to use the angle symbol. When I do this by hand, it's kind of like a less than symbol, but I'll usually try to put a little arc in there to indicate that it's an actual angle symbol. Some students say that it looks like a sideways eye. I don't know. I'm not trying to be clever. It's just a different way to actually write the word angle, but I'm using the symbol to do it, which is how math works. Sometimes we use kind of like hieroglyphs, symbols, to represent stuff. Okay, so I'm going to include the angle symbol first, so I don't actually have to say or write the word angle, which is going to be a lot faster. Just use the symbol right here. There are 3 ways to name an angle. You can name an angle by the letter at the angle or the corner of the triangle. For example, if I were to look at this angle right here, well, actually, I'll say this one. Okay, I could call that just by the name of the corner, which would be angle A, and that would work. On the other hand, what you can do is name it by the corners of the sides that make up the angle. So I'm talking about this side and then this side. These 2 lines make up the angle, but you see the way that I did it, and this would be angle, I went from B, then to A, then to C. And that would classify as the same exact angle, which I had previously written as angle A. Now, of course, you can go backwards there if you'd like. And you can call it angle CAB, which may be more clever because then it spells something. I guess back kind of does as well. Or, we won't see this on this assignment, but what they'll do sometimes, they'll number it. They'll say, look at that number 7 right there, and then you can call it angle 7, whatever. We just won't see this 3rd method in today's assignment. In fact, they don't want this one either. But in the future geometry classes that you guys may take, they may ask for either one of these. Today we're just looking at using one letter to represent the angle. Angle something, which will be important on the second part of the assignment. Okay, so I'm going to name the triangle. It didn't ask for this, but I'm going to do it anyways. You can have it be triangle PAN. Again, some students think it's more clever to say NAP, whatever. Actually, I think there's 6 different names you could use. You could use ANP, PAN, NPA, PNA, whatever. Doesn't matter. I've named it triangle pan. So let's look at the sides on this. Okay, so I got this side right here. That side length I would call side length PA, but if for some reason you prefer to write it as AP, that is okay. Now, some students say, well, that's 2 different side lengths. No, it's the same side length. I just went in a different order for the letters. It doesn't matter. But the same is true for this side length right here, which I could call side length AN. Or if I wanted to, I could call it side length NA. It doesn't matter. And then, of course, the third side length right here at the bottom could be side length PN. Or we could call it side length NP. Okay, because the order of the letters does not matter. And again, on the assignment, you have to use capital letters for these, because generally they use in math for corners of shapes, they'll use capital letters. Next up, we got angles. So each angle I'm going to name 3 different ways, but it represents the same exact angle. So I'm going to start with this angle right here, this one. Okay, so I could call that angle P. And again, this is all you would need on the assignment, but I can go through the side lengths that make it. So I'd go from A to P to N. So if I wanted to, I could call it angle APN. Or if I wanted to go backwards there, I can call it angle NPA. Doesn't matter. Again, our focus is on the first way that we named it as angle P. Next up, we'll go to this angle, and I'm putting a different mark on it just so we know which one it is. That would be angle A, which is the way they want it on the assignment. Or you can go through the corners that make the shape. So P to A to N. So you could, if you wanted to, you could call it angle A or angle PAN. Or you could call it angle, you go backwards there, NAP. Now, it looks the same as triangle PAN, but it's a different symbol. Triangle PAN. This reads triangle PAN, angle PAN. They're different. And then last of all, we'll do this one right here. I'll kind of do the marking different, but it'll be our third angle right there. So again, I on the assignment, it's going to want you to call that angle N, but if you wanted to, you could go through the corners. So like ANP or PNA, doesn't matter. So angle ANP or angle PNA, doesn't matter. Okay, so we've named all 3 angles, and we've named all 3 sides. But again, does it look like we've written more than 3 sides and more than 3 angles? It may. But hopefully we know by now that it's possible to name or to identify the same angle or the same side with a different order of the letters. All of that brings us to this type of problem, which you will see on the assignment. So it's going to say, look at these 2 triangles and determine if they are or are not necessarily congruent. Now, before we get started on this, and some of you may know the relationship right here, but on the assignment, sometimes what they'll do is they won't put a mark right there on this one. So they'll be like, look at this mark, it's not actually there. Okay, now, is that enough information to say that these 2 triangles are congruent? No, because they've only given us an angle and an angle, which isn't going to work. In fact, that doesn't work for right triangles as well. If it were a right triangle and then they showed us the right angle and then 2 of the sides, particularly the hypotenuse and the leg, were congruent, okay, then we could work with 2 parts. But the way this is and the way that you may see it on the assignment, this does not work. Okay, but the way that it is, so let's look at that. Okay, this one should work because just starting out, here I see that I've got this angle with one mark, and then in the other triangle I have the same angle marking. Okay, so that would indicate that I've got an angle A and angle O that are congruent. So that right there is an angle that is congruent. And then moving around here, I've got this side length. I'll call that side length AC, and side length OM, which are congruent as well, so that's side. And notice I went from that angle to the side in both triangles without skipping any parts of the triangle. And then last of all, we've got this angle right here with the 2 marks. Right? Now they're the same markings for both triangles, which means that we are looking at an angle. Angle-side angle relationship is necessarily congruent. So we can click on that. They are necessarily congruent. And when we do that, it's going to pull up a flow chart, like this one right here. Now, we went through the progression already, so I'm going to redo it, though, just so we can review. But to start out, I know that it was this angle right here, angle A, and then angle O, that were congruent, right? And then we had the side length, AC and OM, and then angle C and then angle M, which were congruent. So in the boxes, when you click on these boxes, it's going to pull down these menus. The only reason you should use classify would be in the first box, and that is for hypotenuse-leg relationships. But the way that I have this, I said it was angle, side, angle. So in these pull-down menus, which of them would I choose? Don't worry about this box at the bottom. We'll get to that. But which of these would I choose? Well, the angle, I'm looking for the angle marking. This one, it's got the lines above the letters. That means we're looking at sides. This one, I need the angle, right? So I would click on this one. For the next box, for the side, again, you need the lines above the letters to indicate that it is a side length. So I would have to choose this one. Just keep in mind, after we choose these, we're going to have to enter the actual letters in for them. And then the third box, again, it's an angle, so I would have to click on this one right here. I'm not going to worry about the reason, but the reason is just going to give us all of the congruent statements, and then we choose which one it is. I can see that it's going to be angle, side, angle. Okay, angle, side, angle, right? So it's set this up so that I can actually just enter in the angles that are specifically correspondingly congruent, and then the side length that is also correspondingly congruent. For the sides, since we're going to be using 2 letters, it does not care which order you go in. So just keep that in mind. You can put it in whichever order you want. Now let's start with the angle. So I said it's red, the red angle, which is these 2. And again, they only want the 1 letter for each. So in the first triangle there on the left, the red is marked as angle A. So I just type in A. It's got to be capitalized. And then for the second triangle, that's angle O in red. So that's the angle part. Now the side part. Well, the side, once again for me, I'm going to say that's AC. Now that's the first triangle, so I'm going to put AC in the first box to represent that side length for the first triangle. The second box is where I put the second triangle's correspondingly congruent side length, which is right here from, I'm going to say from O to M. Okay, so I put OM. If on the assignment you put MO, it's okay. It'll still give you full credit. And then in the end, we've got the green one, the green angle, rather. And that green angle for the triangle on the left is angle C. And then the triangle on the right, the green is angle M. So we have angle, side, angle. And the only option there for angle, side, angle, there at the bottom. Again, you'd click on that box and it would pull up angle, side, angle is this one. Okay, now that completes this one, but keep in mind, if these were right triangles, which it may give you on the assignment, this first one, you would pull down the menu, you'd click on that triangle statement, classify triangles, and then you'd have a hypotenuse and a leg, and then down here you choose HL, but you'd have a side and then a side for both of these, because it's a hypotenuse and a leg, which are sides of a triangle. All right, there's our objective. I know when triangles are or are not congruent, just based on those relationships. Don't forget, though, that we have a mastery quiz next time.